Your journey into the digital cosmos begins with a simple yet profound action. You sit before your device, perhaps a gleaming tablet or a powerful desktop computer. Its screen glows with a modern, intuitive interface. You open a web browser, a portal to an unseen world of information. Your fingers hover, then type a web address, a URL, into the search bar. With a click or the tap of an enter key, you unleash a request. This isn't just typing, it's an initiation. You're sending out a call, a query, into the vast, interconnected network we call the Internet. A digital whisper that will soon become a roar of data. This initial command from your browser doesn't travel as a whole thought. Instead, your computer, like an efficient interstellar dispatcher, breaks down your request into tiny pieces. These are called data packets. Imagine each packet as a minuscule glowing beam of light, a tiny messenger carrying a fragment of your intention. Each packet is meticulously labeled with information, including its origin and its intended destination. These digital emissaries are the fundamental units of information transfer. They're designed to be small, agile, and capable of navigating complex pathways, ensuring that your request, even if fragmented, travels efficiently and accurately across the digital landscape. Now, these newly formed packets, these shimmering light beams, need to leave your device. If you are connected via Wi-Fi, your device's antenna broadcasts these packets as radio waves. Think of it as a miniature radio station sending out these signals. These invisible waves carry your data packets through the air, a short but crucial first leap. They travel to your wireless router, a small unassuming box that is in reality a critical gateway. This router acts as the local traffic controller for your home or office network, a vigilant gatekeeper managing the flow of information both in and out of your immediate digital environment. It's the first checkpoint on a much grander voyage. The router, upon receiving these glowing packets of light, inspects their destination addresses. It's a smart device programmed to understand the local network and how to connect to the wider internet. It determines the next hop for your data. For information destined beyond your local network, the router forwards these packets onward. It might send them through a modem, which translates the digital signals into a format suitable for traveling over telephone lines, cable lines, or fiber optic connections. This is the moment your request leaves your personal space and steps out into the broader neighborhood of the Internet, ready to begin its swift journey towards its ultimate destination. Once your data packets, those brilliant beams of encoded light, leave your local router, they embark on a more significant leg of their journey. They travel to your Internet Service Provider, or ISP. The ISP is your main gateway to the Internet's vast superhighways. Think of the ISP as a major spaceport equipped with much larger and more powerful routers than your home device. These industrial-strength routers are designed to handle immense volumes of traffic from thousands, even millions of users simultaneously. Your small packets join a torrent of other data, all flowing towards various destinations across the globe, guided by these sophisticated network navigators. From the ISP's local hub, the journey often involves transmission through fiber optic cables. These are not your average copper wires. Fiber optic cables are strands of pure glass as thin as a human hair. Inside them, your data packets travel as actual pulses of light, zipping along at nearly the speed of light itself. This technology allows for incredible bandwidth and speed, enabling the rapid transfer of vast quantities of information. These cables form the backbone of the Internet, crisscrossing countries and connecting cities. Your glowing beams of data are now part of a colossal river of light, streaming through these advanced conduits, a testament to human ingenuity in harnessing the properties of light for communication. For requests that need to reach servers on other continents, the journey takes a dive. Your data packets, still shimmering with purpose, are routed to massive undersea cables. These are marvels of engineering, heavily armored fiber optic lines laid across the ocean floor, spanning thousands of miles. These cables are the true workhorses of global connectivity, physically linking land masses and enabling near-instantaneous communication across the vastness of Earth's oceans. Imagine these glowing beams of information, your tiny request among them, pulsing through the dark, cold depths of the sea, protected by layers of steel and plastic on their way to distant shores. It's a hidden world of infrastructure that makes our interconnected planet possible. Throughout this intricate voyage, your data packets are constantly being guided. They hop from one router to another, each router examining the packet's destination address and deciding the best next path. This process is called routing. It's like a colossal automated postal system, but operating at unimaginable speeds. Each router doesn't need to know the entire path, only the next best step to get the packet closer to its final server. If one path is congested or broken, routers can even redirect the packets along alternative routes. This dynamic routing ensures resilience and efficiency, allowing the internet to function smoothly, even with its immense scale and complexity, guiding your light beams ever onward. Before your glowing data packets can reach their ultimate destination, a crucial translation must occur. You type to human-friendly web address like. Computers, however, communicate using numerical addresses called IP addresses, such as, this is where the domain name system, or DNS, comes into play. Think of DNS as the internet's colossal distributed phone book. When you type a URL, your computer first sends a query to a DNS server. This special server's job is to look up the human-readable domain name and find its corresponding IP address, the actual map coordinate for the server you wish to reach. The DNS resolution process can sometimes involve a chain of queries. If your initial DNS server doesn't know the IP address, it will ask another DNS server and so on, up a hierarchy of DNS servers until the correct IP address is found. This system is remarkably efficient and usually happens in milliseconds, completely invisible to you. Once the IP address is retrieved, it's sent back to your browser. Now your data packets, those tiny light beams carrying your request, are updated with this precise numerical address. They finally have the exact coordinates needed to navigate the final leg of their journey to the specific server that hosts the website you want to visit. With the IP address secured, your data packets continue their high-speed transit across the internet's backbone. They are routed through various networks, passing through more routers, each one pushing them closer to the server whose IP address they now carry. Eventually, they arrive at a data center. Data centers are fortified buildings housing thousands of powerful computers called servers. These servers are the digital brains and storage lockers of the internet. They store website files, run applications, and manage vast databases. Your request, once a mere thought and a few keystrokes, has traversed a global network to reach one such specific machine. Upon arrival at the correct server, your data packets are received and reassembled. The server reads the request they carry, perhaps to load a web page, display an image, or play a video. The server is a powerful machine optimized to handle many such requests simultaneously. It has the processing power to understand your query and the storage capacity to hold the information you're seeking. It's like a cosmic library, and your packets have just delivered a request slip. The server now prepares to gather the requested information, ready to send it all the way back to you across the same complex network it just navigated. The server, having received and understood your request, now springs into action. It locates the specific files needed to fulfill your query. If you ask for a web page, this includes HTML files for structure, CSS files for styling, JavaScript files for interactivity, and various media like images and videos. The server acts like an incredibly fast librarian, gathering all these components. It then does something familiar. It breaks down this outgoing information into new data packets. Each new packet, a fresh glowing beam of light, is addressed to your computer's IP address, which was part of your initial request. The return journey is about to begin. These newly minted data packets, carrying the website's content, are launched back into the internet. They travel a path similar to the one your request took, but in reverse. They traverse the server's local network, then out to the broader internet, guided by routers through the intricate web of fiber optic cables, potentially recrossing oceans via those amazing undersea lines. Each packet is a piece of the digital puzzle that will become the web page on your screen. These beams of light race back towards your ISP, then through your local network infrastructure, each router along the way ensuring they are on the correct path back to your specific device. As these packets arrive at your local router, it recognizes them as destined for your computer or device within your home network. The router forwards them, again likely via Wi-Fi or a wired connection to your machine. Your computer's operating system and web browser are eagerly awaiting these incoming glowing messengers. As the packets arrive, they might not all come in the exact order they were sent, or some might have taken slightly different routes. Your computer cleverly reassembles them in the correct sequence, checking for any errors or missing pieces, requesting retransmission if necessary, ensuring the integrity of the information. Finally, with all the data packets received and correctly reassembled, your web browser takes over. It interprets the HTML, CSS, and JavaScript code, renders the images, and arranges everything according to the website's design. The web page you requested materializes on your screen. A loading bar in your browser's sleek interface might fill up, and then voila! The information from a server potentially thousands of miles away is displayed before you. This entire round trip from your click to the server and back often happens in mere seconds. A daily miracle of technology, a silent symphony of light and logic connecting you to the universe of information.